Hello. How are you? I don't introduce myself, so you heard everything now from our awesome MC. I would like to ask you some questions. So, who of you attended the WebVR workshop yesterday? Yeah, that's nice. And hopefully now some more. Who of you knows or has worked with React.js? Ah, okay, some people. That's good. Let's see if my pointer works. Yes. Okay, yeah, today I will show you how you can use React and React 360 to create VR experiences in the browser. But before we come to this fun part, I will introduce you shortly to the API that makes this all possible, the WebVR or WebXR API. So whatever library you will use, maybe you'll use A-Frame like in the workshop yesterday, or React 360, you will have a fundamental knowledge about how the WebXR API works and what to consider when designing a WebXR app. And speaking about design, as you may know, good UX design is always essential to every success of a web application. And since VR and AR are relatively new in the browser, I will give you some tips and best practices for creating a good user experience in 3D apps. So, what is WebXR after all? XR basically includes virtual reality and augmented reality and everything in between. So a quick reminder, virtual reality uses a head-mounted display with two lenses to show us a stereoscopic image, one to each eye, and has tracking sensors. And some, like the Oculus or PlayStation VR, HTC Vive, they come with two gamepads for each hand that also have tracking sensors. And with a setup like this, your users are drawn completely into a fully virtual environment that shuts out the real world. On the other hand, augmented reality does not draw your users into the digital world, but it rather superimposes the real world with, or a live view of the real world with virtual content. And this virtual content can be basically anything. Could be real-time information and data enhancing the real world, or it could be virtual objects looking like they exist in a physical world. And last but not least, there's MR, which stands for mixed reality or merged reality. It's not quite sure. But the goal of MR is that the digital content coincides and interacts with the physical world. So you see in this picture, let me just see if my cool new pointer works. No. Let's see here. No. OK. But as you see in this picture, you see the three-dimensional cube thingy, and it's not like a transparent layer above the physical world anymore, but it adapts lighting, it casts shadows, and most of all, it disappears behind the chair. And as you can see, now the X can basically stand for everything, maybe even for technology we do not even know about today. But what we can do today is write virtual reality and augmented reality apps with JavaScript for the browser. And therefore, the W3C Immersive Web Community Group is working on this new API called WebXR Device API. And this API aims first to detect devices with virtual and augmented reality features and get their individual capabilities. And also the API tries to get devices' orientation and position and then render images to the devices with an appropriate frame rate. OK, the new API, as I said, is replacing the now deprecated WebVR API and is currently a draft and unstable, but you can already work with it, maybe not for production, and you can maybe even give your feedback to the people writing the API. So why do we need a new API anyway? What was wrong with the WebVR API? The new API should support not only virtual reality content, but augmented reality content as well. And as you can imagine, when writing things twice, it should be also cleaner, more consistent, and more predictable. And promised are also browser optimizations in regard to performance, For example, they say that you get twice the times the pixels at the same frame rate at a Google Pixel XL phone. And last but not least, and this is very good, we now have an exposed unified input model that works across all form factors. These different input models like gamepads, mouse, touch, and so on. Sorry, it was always a struggle with the old WebXR API and the gamepad API, and now the new API tries to change that. Okay, let's see it in action. What are the steps when we want to create a WebXR scene? So first, we have to check if there are any devices available with WebXR features. For example, this could be your smartphone working with Chrome and the Daydream view. And then, if a device is available, we want to show our users that our website offers a WebXR version. And a common way to do this is showing a button to start the virtual and or augmented reality content. And then, when the user clicks the button, we have to request a so-called XR session from the device. And only within the XR session, we get the device's tracking information, information about orientation and position, and can render images to the device. And last, we can start the render loop, which then renders images to the device, hopefully in a frame rate more than 60 frames per second. Okay, let's begin with step 1, requesting an XR device. So, as I said, a XR device can be basically anything with a screen. On a desktop, you would maybe request a VR headset like the HTC Vive or the Oculus. And on a smartphone, you could request to render to the display itself, but in a stereoscopic way, to use it in a cardboard. Or you would not request render stereoscopically at all. Now here, to request the XR device, we use the Navigator XR object that has a list of XR devices, and the request device method then returns a promise that is resolved with the default XR device, if there is one available. And with the returned XR device, we can now use the method support session to check if the default XR device actually supports so-called exclusive sessions, which means we require a headset to draw on. And if the device is a VR headset that we can draw a stereoscopic view on, the promise gets resolved. Okay, what we did here is then adding a button to the website advertising the VR feature to the user, because at the moment requesting an XR session requires a user gesture to start. And when the user clicks the Start VR button, we can request a session from the XR device with the request session method. And this method takes two optional parameters. One is a Boolean to check if we are requesting an exclusive session. And the second is an XR presentation context, which is the context of the canvas we want to draw on. And this promise gets resolved with an XR session object, which can be used then to get the device's pose and information about the user's environment, and then present images to the user. We use this session then to initialize everything before we start the render loop. So first thing we do is requesting a frame of reference. And this frame of reference defines where the origin of the coordinate system is calculated from and what happens to the origin if the device moves. And there are currently 3 types for the frame of reference. First is head model, then eye level, and then stage. And head model means that the origin of the coordinate system is like approximately a viewer's head, and it stays the same even if the viewer moves. And this is interesting for devices like the cardboard that can only track a user's rotation, head rotation, but not their position. And it's also fitting for viewing 360 panorama photos or videos, because this material is intended to be viewed from a single point. And then there is eye level. This is also, the origin is also a viewer's head, but this time it moves with the viewer. And the last thing, stage, is the origin is approximately on the floor in the middle of the room, and you can use it for room scale VR. And this stays also the same if the viewer moves. To the request frame of reference method then returns also the promise that gets resolved in an XR frame of reference object. And before we start the render loop, we also need to set up an XR layer, which is a WebGL layer. And this layer allows WebGL to provide the bitmaps then to be rendered to the device. And to set a new WebGL layer, we can use a method from the WebGL context of a canvas object, the setCompatibleXRDevice method. And it also returns a promise, and when it gets resolved, we can create an XR WebGL layer with the XR session space layer method and the XR WebGL layer method that requests an XR session and the WebGL context. And finally, then, we can start the render loop by using the XR sessions request animation frame method. In the render loop, we will call this method recursively, which makes that the function will be called 60, or if the headset allows it, more times per second. And within the render loop, we can do calculations needed to draw the next frame. For example, like here, we are getting the device's position, and then draw something on the screen if we have a correct position. And also, if your app listens to user input, you could process it here before calling the request animation frame function again. Yeah, and that's basically it. You may want to end the XR session, either manually or by listening to the end event. This can be triggered because maybe a headset got disconnected. And the end method also returns a promise that's resolved when the presentation to the VR device has stopped. And once the session has ended, you may want to continue rendering your scene, but in a non-stereoscopic way, and then you can use just Windows request animation frame method. OK, what we did till now, so all this code could look like this. And I think it's cool, but you may want to support more than just VR headsets that have a stereoscopic view. And a common solution to do this would be to render your 3D scene in a non-stereoscopic way, then working with the gyroscope of a smartphone or with touch or click, drag, and drop input to look around the scene. And this is often called magic window because it has the appearance like watching through a window to another world. So whenever stereoscopic rendering is not available or yet requested, you could show the exact same scene in a magic window. And the cool thing about the magic window mode is that it does not require a user gesture. So you can just render your content to the page when it was loaded and not requiring the user to click any button or similar. And to start the XR session for the magic window, you can use the XR sessions creation method exclusive and set it to false. So with this in mind, you could provide a WebXR app that initially renders the magic window, maybe using the smartphone's gyroscope if available, and then you could check if there are any VR devices that support exclusive WebXR sessions, which means checking if the user has any VR headset attached. And if so, you could render a button requesting an exclusive session to start the stereoscopic rendering. OK, let's shortly talk about one of the most obvious problems of the VR in the web, or I guess the web in general, which is the various devices, screen sizes, browsers, operation systems, input method, and so on. I mean, it's not really, your users won't have the optimal VR hardware, especially when browsing the web. Your users won't have like the Oculus with a 6 degree of freedom VR headset and 2 6 degree of freedom tracking sensors in room scale VR. And not everybody, if you go making AR stuff, not everybody has a smartphone with AR Core, AR Kit support. So your users may use something like the Google Cardboard or Daydream View, the Gear VR, which is a 3 degree of freedom headset that does not track the position but only the rotation and has no or only one input controller. So how do we handle this situation? And I think it's easy. I think we should start supporting or making your experience work on all devices with less features too, and then improve your experience step by step. So you could use the WebXR polyfill to make your experience work on more browsers than browsers that support WebXR. And you could also use the magic window on a desktop computer or on your mobile phone where stereoscopic rendering does not make sense. And if you have like devices that do not support rendering 3D at all, you could just show a static website, static image, video, and so on. In the future, the WebXR API will also implement functionality for AR. So you will be able to start an AR session, get methods to do hit tests with the real world and detect planes and surfaces, and you will be able to set anchors. And these anchors will allow us to specify poses, which is orientation and position of virtual objects in the real world. And so whenever your knowledge of the real world improves, maybe by more tracking over time, these poses can improve themselves too. But yeah, this spec is really not ready for production yet. You can try it out. I have a link at the end of the slides where you can find more information. But for the moment, what we can do is using libraries like React 360 or also A-Frame that will make it easy for you to create 3D and 360 and VR experiences that will run in many browsers. Okay, so React 360 is built on top of React, and it is mainly used for creating 3D and 360 interfaces that are driven by user interaction or events. And since React 360, which was called React VR then, was released in, I think, April 2017, the most common use cases in the web were panorama photo tours or interactive experiences to promote news and products. And so today I will show you some code to create a simple panorama photosphere that I took with my 360 camera to give you an understanding of how this works. As I said, there are other libraries, and the most important one, and one of my favorite ones, is definitely A-Frame by Mozilla. And both libraries will make it easy to write performant 3D and VR code that will run on many browsers and devices. The main difference between those two is that React 360 is obviously written with React.js, and A-Frame is written using declarative HTML-ish like components. And when you would choose React 360 for handling many user events, user interaction, creating 2D and 3D user interfaces, A-Frame is the library you would choose if you have like complex 3D worlds with many 3D objects, complex shaders, and post-processing. So both libraries are at the moment, I think, using the old WebVR API. But for A-Frame, there's a repository that already uses the new WebXR API. I have the link also at the end of the slides. And I talked to Andrew Im, one of Facebook's React 360 core developers, and he said they will switch and support the new API once it's not in a draft stage anymore. So we could just use both libraries and wait for them to swap the API in the background. So I guess that's cool. Okay, React 360 comes with a CLI, so all you have to do is install the CLI, create a new project, enter the directory, start the server, and then navigate to your local host. And like React Native, React 360 is made of two pieces, the React application and the runtime, which turns the React components into 3D objects. And this separation is made to avoid all render blocking behavior and always keep a high frame rate, which is especially important in your VR apps because your users will really feel unwell if the frame rate drops or if the app gets jittery. So it should be more than 60 if the device is supported. Okay, this is the scaffolded project folders, and we will take a look at 3 of the files, the client.js, the index.html, and the index.js. So this is the index.html, and I only show you the body because there's nothing special happening in the header. The only thing we're doing here is loading and mounting the JavaScript code with React 360 in it. The first argument is our bundle, where the main code of the application is in. And the second is the parent element, where we want to render a canvas. OK, now this is the client.js that gets defaulted by the CLI. First, we are here importing a React instance from React 360 Web before defining and executing the init function. And within the init function, we create a new React instance with some options. And then, with render to surface, we actually render what is defined in the index.js into a 3D scene. A surface is, by default, like a cylindric layer on which you can draw 2D user interfaces. And last thing that happens here is setting a panoramic background image. So this is the index.js. I left out all the imports and style sheets to save some screen space, but the interesting thing is the JSX code anyway. Who knows React Native? Only some, yeah. So like React Native, you may know this, React uses view and text components that you can use to curate and style your 2D content. And then that gets rendered on the cylindric surface. So this is how it would look. Oh, it's vertical. I don't know why. I recorded it on my smartphone, but let's see. The next example should be better. So to go from there to a photo gallery, we just have to adjust the client.js and the index.js. So within the client.js, we remove the background image and change the render to surface function by giving the create root function an object with all the photos as an array as second parameter. And these are the panoramic photos in an equirectangular format, which is specified here as format2D. And the JSX code within the index.js, it looks like this. And as you can see, we are using two more components, VR button and background. And VR buttons are non-visible container elements, like a div, for example. But they detect clicks and other click-type behaviors and of various input devices. And to give it an appearance here, I just added styling and a nested text component. And the background component is actually a custom class that listens to prop changes and then sets the environment background image. And by adding click listeners to both buttons, the previous photo button and the next photo button, we can change the index saved in the slideshow state. And with this, we can set the current background image of the background class. And that's basically all. Nice. Now it's running the correct format. This is basically all you need to write to create a full sphere photo gallery that works in a magic window and on a VR headset. I think the next photo is also showing the stereoscopic rendering. Yeah, this is a conference in Germany. You should all attend. Yeah, as you can see, if you know React or React Native, writing React 360 code is not totally new for you. But what's new, however, is how all user interfaces and interaction works. So let's talk at the end about user experience design for WebXR applications in general. And I will include some tips for AR either, because you probably want to start on working on AR apps too. So when you start thinking about user journeys or interaction patterns, you will find out soon that our learned best practices and patterns are not always working in a three-dimensional environment. You cannot apply all your well-known patterns without thinking in a 3D app from your 2D patterns. Sorry. And also, since 3D and VR and AR are new in the browser, there are no really established UX design patterns yet. But there are some best practices that I can share with you. And the first, this is not new. You should always give your users feedback and respond to all interaction immediately. So the feedback can be visible or haptic, like, for example, vibrating controllers, or it can be made of spatial sound, or you use all this stuff to combine together. And you could also consider the use of a reticle with different conditions for idling and hovering in active states. When we think about it, we are like in a kind of similar situation like we were in 2007 or 2008 when the iPhone and with it the first mobile sites appeared. And back then we had to reconsider how we present our information on a tiny screen or on screens with various sizes and ratios. And today we have to think about how we present the content to our user when there's no more separation between your content and your users. It's like your users are finally in your application. And therefore, all VR applications or AR applications do not have a limited viewport, but on the contrary, they have an infinite canvas, and a user only has a limited field of view. But this field of view, of course, may change because all users can rotate their heads and look around. So how do we make sure that a user finds what he or she is looking for? To do this, you guide your user's attention with gaze cues. And therefore, you could use, again, spatial audio, lighting, color, or even virtual creatures with eyes that catch your user's attention. And another tip is that hints are more obvious for a user if you provide them in the 3D context and not as separate text elements. So it is more intuitive if a user is able to manipulate these objects directly in the scene and not via separate text elements. Yeah, you see the rotation indicator on the right is much better than the text-based hint on the left. There's one illustration and one name I'm always mentioning every time I talk about VR and UX design, and this is Bo Cronin's hierarchy of needs in VR. And the hierarchy shows that the two most important needs in VR are comfort and interpretability, and only afterwards comes usefulness and delight of your application. So comfort means that a user can use your application without feeling unwell, and interpretability means that the digital world feels convincing to the user. And only if these two needs are satisfied, a user gets this feeling of being present in the virtual world, which is what you want to achieve. While working on my talks and prototypes, I added another part to the hierarchy, which I find even more necessary than comfort, and this is safety. So what can we do to make our users feel comfortable and safe in an augmented reality context? One thing you can be sure of is that your users won't use your app in an optimal AR environment. There is probably not enough space, there are probably no large surfaces and poor lighting conditions. You have to accept that you have no control at all over the scene. So consider all these situations and maybe think about adding different features for these kind of situations. Then, during a design process, it's important to think about your user's context. For example, consider the environment you're using your apps in. If your app is mainly used at home, it can be designed for a longer usage. But if your app is mainly used outside, you should support super short interactions. Thinking and testing interactions is important in AR, but as you can see in VR too. And to reduce the risk of making a user run into physical objects or other people, avoid encouraging all large and sudden movements. And the last tip for a good user experience in augmented reality apps is avoid fatiguing your users. So respect that holding the smartphone or even the iPad at a certain angle can really be exhausting. So consider to reduce the amount of the required movement and maybe place objects at certain distances. Okay, what can we do to make our users safe and comfortable in a virtual reality context? First of all, you should avoid creating environments that may trigger phobias, like large empty rooms or small rooms or underwater environments hates, especially without warning them beforehand. And also, you do not want to move things fast towards the user, which is the camera, especially if these are sharp or dangerous or gross things. And also, you do not want to attach things near the camera or directly to the camera. So a head-up display, as cool as it may sound, is not the best thing to do in VR. And another example, if you want to use splash screens, they should be located in the 3D world and not being attached to your camera. Last but not least, respect a person's private space around them. So do not allow objects or avatars or even other user avatars enter this space. Okay, one last thing we have to talk about when it comes to VR and comfort is simulation sickness. Simulation sickness occurs when your sensory inputs are not consistent. For example, this would be an example, but I think it's too short to get him sick. But for example, if the app tells you you're in a car race and you're just sitting still in a room, and there are some best practices you can regard to avoid causing simulation sickness. So first of all, do not move the horizon and do not move the camera. And also, don't use acceleration. So constant velocity is okay because we cannot feel it, but acceleration and deceleration, so something like this, should be felt. And when there's no feeling, simulation sickness will occur eventually. And then last, avoid flicker and blur in your designs because they implicate movement, and consider adding a stable focus point to your scene. Okay, that's basically all from me. I don't have a timer. I don't know anything about the time, but that's basically all from me. And if I had a free wish, I would like you to remember two things of this talk. So first, respect your users and test your products continuously with real users. Also, you will get, as a developer, you will get like resistant to simulation sickness. You should always test your product on other users. And then second, if you like experimenting with all these new APIs and new libraries like React 360 or WebXR, give feedback to the persons writing them. So here's a link of the WebXR device API repository, the React 360 repository, and also the new A-Frame XR repository, where you can try it out and then maybe create issues, give feedback. So yeah, get involved if you like, and yeah, that's all from me. Thank you.